Okay guys, and welcome to the final video on the multiplier mini-series. And in this video what we're going to do is go through all the previous paper 3 questions on the multiplier that have come up in previous years for the IB paper 3 exam. Okay, so the very first thing is there's nothing on this page that's actually important, but I just wanted you to see that, okay? So the first thing we've got to do is turn over the page, and excuse me while I'm flipping pages and stuff like that, and I'll wait for it to get back into focus, and I'll even press this button to make it slightly better. Okay, good. Now, okay, government economists have estimated that citizens of Fairland, okay, this bit here I'm reading, you can ignore this, okay, it's from another question, all right? So government economists have estimated that citizens of Fairland spend 10% of any additional income on imported goods, okay, imported goods. That's an MPM of 0.1 as we see here, okay, and pay a tax rate of 20% on every extra dollar of income. That's an MPT of 0.2, and the marginal propensity to save for Fairland citizens is 10%, and that's an MPS of 0.1. Now, I would hope that certainly if you've watched my previous videos, you will have known that this is one of the 2 final ways that you can use the multiplier formula. So what I'm going to do now is I'm going to start to plug these numbers in, okay? So what I'm going to do is 1 over, okay, so we've got 0.1 plus 0.1 MPS here, MPM here, plus MPT here, plus 0.2. What that equals is 1 over 0.4, which simply equals 2.5. Okay, so all I'm just going to write down here, the multiplier is 2.5. Done. What's the economic meaning of that figure? The economic meaning of that figure means that any initial injection into the circular flow of income in Fairland will cause national income to rise by 2.5 times that injection. Okay, that's very important. Now, this is literally what I have just said. Okay, so it says, using your answer to part 1, calculate the increase in government spending necessary to increase nominal GDP by 100 billion. Okay, well, what I want you to know is that the resultant increase in national income, which is why I could have written delta GDP, equals the change in the injection times the multiplier. Now, if I divide both sides, okay, by the multiplier, this will cancel. And what I'm just going to do is I'm just going to write this down actually here. Divided by the multiplier. Okay, and that equals the change in injection times the multiplier, all divided by the multiplier. Okay, cancel. And now what we've got here is we're going to skip a line. We're going to say, okay, so it's the change in injection divided by the multiplier. And what that equals is the change in government spending required. Okay, just a simple bit of maths, okay? Instead of injection, I've just labeled it as the change in government spending. Now, I'm going to have to do all my work on the bottom here, but that's okay. So, they want national income to change or increase by 100, okay? We have to divide that by the multiplier, which we've already worked out, and you can just see that up the top, which is 2.5. And 100 divided by 2.5 equals 40. And the answer is 40 billion. Okay, so what we're going to say is, okay, the change in government spending required equals $40 billion. The multiplier will do the rest. The extra rounds of spending as a result of the increases in income caused by other people's spending will bring national income up to 100 billion. Okay, excellent. I've done that. We're on to a winner, guys. We're working well here. Okay. Now, again, you can usually ignore all of this, but here is the bit that we're looking at. Country beta is assumed to be a closed economy. That means no international trade. If there's no international trade, that means no MPM. A closed economy with no government sector. If there's no government sector, that means no taxes and no MPT. Consumption in beta increases by 80 cents for every $1 increase in national income. That's an MPC of 0.8. Okay, remember that. I'm going to write that down here. MPC equals 0.8. Okay. In the first quarter of 2019, investment rises by 2 billion. Calculate the maximum possible increase in gross domestic product, GDP, national income, Y, that could result from the rise in investment. Right, well, we already found out that the MPC is 0.8 because of what we've read here. The multiplier is 1 over 1 minus the MPC because that's all the information we have, because that's all the pertinent information, because there's no imports or exports and there's no government. So what we've got here is 1 over 1 minus 0.8 equals 1 over 0.2 equals 5. So what our answer here is, the multiplier equals 5. That means any initial increase or any initial injection into the circular flow of income of country beta will cause national income to rise by 5 times that initial injection. Okay, so now what do we know? Well, we know the change in GDP. Okay, that equals I'm going to say the change in injection, okay, times the multiplier. Okay, so what we've got here is that the change in GDP equals the change in investment. Investment rises by 2 billion, so that's 2, multiplied by the multiplier, which we've already worked out as 5. So that's 5 equals 10. Okay, so now what we're saying here is that the change in GDP, which is the maximum change, equals $10 billion. Again, I really hope that makes sense, guys. Just get very, very used to the formula. See what I'm doing, okay? And any questions, of course, you can put in the comments below and I'll try and get back to them. Okay, now, an excellent question here. I really like this for the simple reason that it goes into the process and explains it. So I really want to take my time with this question, okay? Country delta, which is different to beta, is an open economy. So that means there are imports, which means there's more leakages because there's an MPM. An open economy with a government sector. That means that there are more leakages again because it's got a government, so there's an MPT. Investment rises by 2 billion in both delta and beta. Explain how the size of the multiplier and the resulting effect on gross domestic product might be different in the two countries. Okay, well, what we know is the bottom line for the multiplier using the full formula has 3 leakages. That means the bottom line using the full formula is going to be the bottom line is going to be bigger, leading to a smaller multiplier. Okay, so let's keep that in mind. Because delta has an MPM, which is a leakage, and an MPT, which is another leakage, the multiplier in delta will be smaller, since there are more leakages in delta than there are in beta. This is due to the existence of imports and income taxes. Now, if we look at the multiplier in beta, which is a closed economy with no government, then we have 1 over the MPS. There's only one leakage. We want this to be 0, which I think mathematically it's undefined, I know, but may lead to infinite national income. Okay, but we're economists, we know that can't be true. But if we go further on, the multiplier in an open economy with a government sector, with taxes like delta, is 1 over an MPS plus an MPT plus an MPM, all right, which means there's 3 leakages. So at each stage of spending, All right, more money has been taken out of the system, been taken out of the circular flow by leakages, by import buying, and by the government taking taxes. So therefore, an increase in investment will increase real GDP by smaller successive amounts in delta than it would in beta, as a greater proportion is withdrawn in delta at every stage before additional spending takes place. As a result, the effect of an injection on real GDP will be smaller in delta than in beta. And the reason is, if I spend €100 in your shop, okay, and there's no government and there's no imports. Now, even with an MPC of 0.9, you're going to spend €90 elsewhere, okay? But let's say that's the next round and the next round and the next round and the next round. But let's say that there are imports and taxes. Well, you're not going to spend €90 in the next round because you have to pay, you're going to buy €5 worth of imports and €5 paid in taxes. You're only going to spend €80 in the next round. And that's going to lead on to the next person and the next person and the next person again. So what I really want you guys to see here is that if the more leakages there are, the smaller the multiplier is. And I think it comes to these. Now, I think that's a perfect answer to give. Okay, so I really would try to commit something like that to memory. Okay, well done, guys. Now, just moving on. I'm trying to keep this quick as I can. Okay, so on to 3A here, right? Now, in country Z, for each additional €1 of income earned, 4 cents is saved. So that's an MPS of 0.04, if you can read my chicken scratch there. 15 cents is taken as a tax. That's an MPT of 0.15. And 6 cents is spent on imported goods and services, so an MPM of 0.06. Okay, so we've got an MPM, we've got an MPS, we've got an MPT, so that means our multiplier has to take all of those into account. If there wasn't an MPT, you would just be 1 over MPS plus MPM. If it was a closed economy and there was no imports, it'd be 1 over MPS plus MPT. Okay, if there's no imports and no government, it's just 1 over MPS. You just use the figures that you have. You leave out the ones you don't have because they're not important, they don't affect it. So what I've just done is I've plugged all these numbers in, okay, and if I add the bottom line, 0.04 plus 0.06 is 0.01, or it is not, it is 0.1, and 0.1 plus 0.15 is 1 over 0.25, which equals 4. So I'm just going to write down here, okay, just move this up so you can see. Okay, answer, the multiplier is 4. Okay, what is the economic meaning of this figure? Well, any initial injection into the circular flow of income will cause national income to rise by 4 times that injection. Okay, now what are we doing next? Okay, excellent, 3B. I'm just going to adjust my pages again and excuse the glare. Okay, now, very good lights in this apartment. Okay, so the government of country Z intends to increase government spending in order to increase GDP by $950 million. Using the previous answer, calculate the increase in government spending needed to bring about the desired change in GDP. Okay, we know that the resultant change in GDP, Y, national income, whatever, equals the change in injection times the multiplier. The change in injection in this case is going to be the amount of government spending up here, okay? So how much do they need to spend? Well, we have already calculated that the multiplier was 4 in the previous question, right? So if we want national income to increase by 950 million, the government doesn't have to spend 950 million. It has to spend 950 million divided by 4, okay? And why? Because the multiplier will do the rest. Okay, so it's 950 divided by 4. And what does that equal? That's just the change in government spending that's required to cause national income to rise by the desired, up here, 950 million. Okay, no problem there. So if we do that, and here's something I've prepared earlier, but we get an answer of $237.5 million. I put the dollar symbol there. And that equals the change in government spending required. Okay? And if you want, sometimes it's easier to do this, guys, as you'll have seen in previous videos. You can write it out like full proper numbers. In this case, there is literally zero need to do that. but sure, why not while we're here. Now, have we done all that? Yes, we have. Okay, excellent. We're doing well here, guys. Now, what are we doing here? Okay, forgive me again while I adjust the pages. Okay, so sketch an ADAS diagram to show the impact of the multiplier. Right, well, looking at the previous answer, AD was somewhere, let's say, along here. This is AD1. Now, the first thing I want you to know is I have labeled the axes, price level. You can write PL, APL, average price level. You get away with a lot, okay? And real GDP, you can write real income, you can write or Y, you can write anything, okay, essentially. So again, you get away with a lot, but let's label everything. The second thing I want to bring to your attention is just because it's easier, I'm using the Keynesian aggregate supply curve, because that means there's no need to worry about two extra diagrams like the short run, the long run aggregate supply curve and the new classical model. Okay, so let's label everything while we're here. We've got AD1. Now, what we are claiming is the government in the previous question, we worked out that they spent an additional 237.5 million. And that brought us out to AD2. So what this represents here, this shift out here represents the change in government spending. Okay, then what we're saying is something else happened. This kicked off a number of extra rounds of spending, and that caused the aggregate demand curve to shift out even further. And what accounts for this further increase in aggregate demand? And that's the multiplier effect. Okay, now just to be honest, you didn't need to label these things like that, but that's the idea. You needed to show that there was two shifts in the aggregate demand curve. One occurring from the initial increase injection of government spending, and the second was the multiplier effect acting on this initial injection. Okay, so we know what that is. Now, on to the next thing. Again, another excellent question that I really, really like because it goes to the heart of what the multiplier process is. Explain the multiplier process, which causes the final increase in GDP to be different from the initial increase in government spending. Okay, so what we are saying here is spending by one person. If I go into your shop and spend €100, that becomes income for you. So now you're richer and you're like, oh, I'm richer. I'm going to spend more money than I had anticipated because I'm richer than I thought I would be. And then you go into another shop and you spend some of that €100. It doesn't have to be all. Let's say €90, an MPC of 0.9. And now they're richer and they say, oh, I'm richer. I'm going to spend more money because I have more money than, or just I have more money. It doesn't even need to be than I expected. So that's the important, and that happens over and over again. Okay, so spending by one person represents income to another person. Therefore, an increase in government spending, okay, they're an economic agent, an economic actor, leads to a series of additional increases in income because I spend it in your shop, you're richer, you spend it in somebody else's shop, they're richer, they spend some of it, again, some of it, an MPC of it, in somebody else's shop, now they're richer, they spend some of it in somebody else's shop, and so on down the line. Therefore, the eventual increase in GDP will be greater than the initial increase in government spending. Now, I will just take one moment. I'm sure I'm going on far too long. But what I want you to understand is always, always, always that production is wealth. Okay, so we see that there's an increase in production, but I want you to understand why. So when I go into somebody else's shop, and if everybody does this, they go into somebody else's shop, and they say, I want to buy more and more and more and more, because now we're all richer, now we're passing this government income that those that received it, building the roads and the bridges and the hospitals and the schools and all that kind of stuff, now they're richer, they've got more money in their pockets, so they go into somebody's shop. Enough people do that. They have to ring up their suppliers and say, listen, you've got to double, triple, quadruple our orders. They say, we can't do that. And then I shout down the phone at them saying, you better just hire somebody else. So they hire unemployed workers, and now these unemployed workers go from not producing to producing, and that's kind of the process, just so you can understand a bit better. I've probably added to confusion rather than understanding, so my apologies. Now again, with a lot of these things, there's a lot of stuff that we can ignore, so I'm just going to get under here and I'm good. Okay, now this is table 2. We have the MPS, the MPT and the MPM. Using the data in table 2, calculate the value of the Keynesian multiplier in South Korea. I don't know why I couldn't say that word. Okay, well, the multiplier formula is thusly. Okay, the MPS taken from this is 0.3, MPM, because I'm a creature of habit, is 0.2, and MPT is 0.3. Now, if you'll forgive me, I'm just going to go below the writing here, and I'm going to write down what does this equal? 1 over MPS 0.3 plus 0.2, that's 0.5, plus 0.3, which is 1 over 0.8. Okay, I have worked that out to be 1.25. That is the multiplier. So I'm just going to write down answer. Multiplier equals 1.25. Okay, what that means is, what's the economic significance of that figure? Well, the economic significance of that figure, and yes, I'm saying it again, means that any initial injection into the circular flow of income in South Korea, will cause national income of South Korea to rise by 1.25 times that initial injection. Okay, excellent. Now, I suppose I better come here first, right? I better come here first to bring your attention to this. Looking at this table, we see in 2009 exports, which is an injection. An increase in exports will cause an outward shift in the aggregate demand curve. Okay, that's an increase in an injection, and we have to multiply that by the multiplier. Okay, so exports went from 412 to 448. We were given that in the question. Okay, so using the multiplier calculated in the previous question, don't be worrying about any of those numbers, calculate the change in South Korea's real GDP brought about by the rise in its exports from 2009 to 2010. Well, what was the increase in the injection? This is the important thing. What was the increase in the injection? Well, it was 448, which is year 2, minus year 1, which is 412. There was an increase, an initial extra injection, but an initial injection in 2010 of $36 billion. So we know that the change in national income equals the change in the injection times the multiplier. All right, so what we're saying here is we've got what's the injection? Well, it's the change in exports times the multiplier. Okay, well, let's work this out then. The change in GDP equals 36 billion multiplied by 1.25, which is what we worked the multiplier out to be in the previous question. Therefore, the change in GDP equals simply 45. Now, I don't know why I do this. Maybe I'm just my teachers were strict when I was growing up, but I always write the answer, the change in GDP equals. Now, this is important, to write down the currency symbol and the amount. You actually lose marks if you don't write these things. So $45 billion national income increased in South Korea as a result of the change in exports. Okay, that's that one done. And like a lot of this stuff, that is completely irrelevant. Okay, now on to, I believe it's the last question, and yes it is. Okay. Guardia's investment. This is why I write it out, guys, as change in injections. And I'll actually come back to this, okay, the previous page here. Okay, the change in GDP equals the change in injections times the multiplier. Okay, remember that. Take a photo of that. Take a mental picture of that. Okay, so look at this now. This country, Guardia, which has the, I was going to say the euro. No, the currency of the gamma. Okay, so Guardia's investment. What's investment? What's the definition of investment? The production or purchase of capital goods increased by 11 million gamma. That's there. You might as well say dollars if you want to think about that. All right, but don't write dollars. You'll definitely write gamma. Okay, so 11 million gamma in the last month. In the same month, however, not all of that is an initial injection, because its government spending decreased by 8 million gamma. Okay, well, what's the change in injections then? All right, it has been estimated that the marginal propensity to consume, the MPC, on domestic goods and services of Guardia is 0.75. Calculate the maximum possible increase in real GDP in Guardia that could result from the changes in investment and government spending. And the reason why it's saying the maximum possible, because as we've seen, and again, I shall go back to a previous question, not all of this increase in aggregate demand is resulting in an increase, in a direct increase in real GDP. What we're going to also see is that some of it is eaten up by inflation. Okay, so then what's the maximum possible? If there was no rise in prices, that entire change in spending would just be represented, would just cause a change in real GDP, okay? Right, well, what's the change in the injection? Well, we've got an increase of 11 million, but we've got a decrease of 8. So the change in injections is a plus 3 million gamma. We don't know anything about taxes or imports, so we ignore it. It's just that simple, okay? So that is, and we're told that the MPC, and I'll write this up here actually, MPC equals this, 0.75, okay? So what we've got now is 1 over 1 minus 0.75 equals 1 over 0.25 equals 4. That 4 is the multiplier. I'm going to say it again, guys, I apologize. What's the economic significance of that figure? Any initial injection into the circular flow of income in Guardia will cause national income of Guardia to rise by 4 times that initial injection. Well, we know that the initial injection now, the net initial injection, is 3 million gamma. So what I'm going to do now is I'm going to bring your attention to the change in GDP equals the change in injections times the multiplier. So what's the change in GDP, in real GDP, which is assuming that none of this caused any inflation, is the change in injection, which is 3, multiplied by the multiplier, which is 4. We've got down here answer, change in GDP, and if you want real, and real, the maximum possible change is 12 million gamma. Okay, guys, that's the end of all of the mathematical questions for paper 3 on the Keynesian multiplier. Thank you so much for watching them all. I really hope this helped you. Very best of luck in your studies, and I hope to see you again in the next video. Bye for now.